Hello, my name is Albert Junu, a STEM coach at Apex STEM Lab. In this video, I'll be showing you a game project built with Python programming in Pictoblox. This is lesson 2 of my second day as a participant in the STEMpedia Empowering Educators Bootcamp. A bootcamp that sought to teach educators AI, robotics, and Python programming. In this project, we built a very simple game and an interesting game using Python programming in Pictoblox. It's simply a game that is a maze runner game where the sprite will need to run through the maze to get the reward of an apple. So to explain the code of this game, simply we have to declare our sprites, which is the ladybug sprite as I have here in my project here. Then for the game to start, we have to set the sprite to a particular location. Therefore, we declare that the sprite should go to XY, which is on the XY axis in our stage. Our sprite should go to -143 and -65. That is on the X and Y axis respectively. Now, in this game, we are going to be using a while loop. And a while loop is a forever loop, which means whichever function or condition we declare, it should continue running until the code breaks. So in using a while loop, we now declare that our while loop is 1, which means it should be true, meaning any code that is running after this should be a loop, a forever loop. And that has been declared as a function here. Now, we are saying if our up arrow key is pressed, so we write that by saying sprite.isKey pressed, then our sprite should be in the direction of 0 degrees, meaning it should be facing upward, and the sprite should move 5 steps. Now let me press my up key on the keyboard and let's see what happens on our stage here. Okay, before that I have to run the code. So let's go through the code before we run it. Now, secondly, I am also saying that whenever the down arrow key is pressed, our sprite should set the direction to 180 degrees and it should move 5 steps. And don't forget, this is a forever loop, so it will continue performing these actions while you click on the up arrow key or the down arrow key. So the same thing is being done for the left arrow key. So we are seeing when the left arrow key is pressed, the sprite should set its direction to -90 degrees and the sprite should move 5 steps. Now, the same thing to the right arrow. When the right arrow key is pressed, the sprite should set its direction to 90 degrees and move 5 steps. Now, to make this game interesting, we are going to say that whenever our sprite, which is our ladybug, whenever our ladybug here touches the walls of the maze, so it is assumed the black lines are the walls of our maze, and whenever it touches the walls of the maze, then it should say game over. Now, because the walls cannot really be seen there, we use the black lines as the wall. So in order to give the sprite this function or this instruction to obey, we need to use the color. So that is why we say if our sprite is touching the color, and the color code for black is 000, we are using the RGB color code, and 0 for red, 0 for green, and 0 for blue. And let's see what happens if the sprite touches this color on our stage. So we are saying that it should set the direction to 0 degrees. The sprite should come back to this location, our XY axis, which is the original location it started with from the beginning. Then our sprite should say game over for 2 seconds. So the number here represents the wait time, which is 2 seconds. So that is what makes the game interesting. Now, we also want to write a code for our sprite whenever it gets to the final destination. Now we are saying if our sprite is touching the color, remember we use the same color function here. If it is touching the color, and here too we are using the RGB color mode, and 255 is for red, 0 is for green, and another 0 is for blue. And this color code here stands for red because we have a red apple up here. And whenever the sprite gets to this apple and touches it, it should say you won. And you should say that for 5 seconds. Then break, meaning our whole loop will break. Without breaking the loop, meaning this code will continue running even if it touches the apple. So we want that when this happens, then our game is now over. You have won the game. But for us to start at the beginning again and play the game again, we will have to declare this at the beginning, just like it has been done here, so that whenever you run the code again, our sprite comes back to its original position and start over again. So now I'm going to run the code and make the stage big. Let's see how this game works. I click here to run. I'm going to make our stage big here. And let's see how this runs. So you can see as I click on my up arrow key, my sprite is moving. So let me deliberately commit an error by touching you can see immediately it touched the black lines, which is the wall of our maze. Our sprite goes back to the starting point. So let's see what happens if it gets to the apple. Okay, my computer is running slow a bit, but in the game we could also increase the speed of the sprite, the number of steps it moves anytime we click on the arrow keys. So I'm going sideways. Don't forget, if we touch the walls of the maze, our game is over. I'm trying so hard to avoid that. This is a very interesting game. Okay, we're almost there. Yes, so you can see we've won the game. So this was a very beautiful game we built during our second session or our second lesson. A very nice and interactive game, and you could see all we used was a loop. And finally, you have to break the code. This is very important once you win. Thank you very much. Have a good day. My name is Albert Duno once again from Apex STEM Lab. Bye bye.